Alright guys, welcome to our channel Code with Sunny, and today in this video we will be talking about the linked list cycle second problem of LeetCode. It is the medium problem. Its index is 142. Okay, so you guys must be interested to know what is the first problem, linked list cycle 1. So you can go over there, you can see a linked list cycle and find the duplicate number. Like actually the second problem is like linked list cycle 2 is an extension of the very first problem, which was an easy one. And this problem, find the duplicate number, this problem can also be solved using the same concept that I will be talking right now. Okay, so I would strictly recommend you guys that if you have done with this problem, like if you are done with this problem, then you must go over this problem, find the duplicate number and try to solve this problem with the help of this concept that I will be teaching it right now. Okay, and like you can see also that I have done the submission for this problem also and for this problem also, because they are actually interesting ones, so it would teach you some new concepts. Okay, so for now we would be discussing this problem. Given the head of a linked list and we have to return the node where the cycle begins. If there is no cycle, return the null pointer. Okay, so there is a cycle in the linked list. If there is some node in the list that can be reached again by continuously following the next pointer. So I will explain it out with the help of diagrams what this entire thing it is. For now, let's look out some important point. Note that pose is not passed as a parent. Okay, do not modify the linked list. We are not going to modify the linked list. And you can see the number of nodes is in the range up to max of 10 power 4. So we would be thinking for O of n time solution, and like O of n log n solution also passes, that I will be first explaining how it can be done with the help of O of n log n time in O of n log n time. Then I would be optimizing it to O of n time. Okay, can you solve it in O of 1 constant memory? Yeah, I can solve it. So yeah, okay, so let's understand this problem with the help of diagrams. Okay, so suppose like let us take some linked list. Suppose the number 1, then 2, then 3, then 4, and then 5. Okay, so this is a linked list. Okay, and you can see there is not a cycle present over here, not a cycle present over here. So in that case, what we need to return is the only null pointer. That will be our answer. Okay, but what about the case when there is a cycle present in this linked list? So what I'm gonna do is let me denote it by some like 7, and suppose this is a cycle. You can see, let me just change it the color and denote it right over here. You can see this is the cycle present in this linked list. Okay, so we need to find out the very first node, that is, you can see where the cycle begins. Okay, you can see our answer is this node. Our answer is this node. So how we are going to approach or find out this node? Okay, so the very first thing that you need to understand is you need to check it out whether there exists a cycle in this linked list or not. So you are going to check it out whether there exists a cycle in this linked list or not. So there are many ways to do that. Like you are going to use a hash map where okay, so not saying it has map, you are going to use a set which stores the node's address, and whenever you will encounter the same node address again, you will just claim that yes, this is our uh, beginning of the loop present in the linked list. Okay, so let me explain it out what I am trying to say. It's like suppose you are going to maintain a set and set of list node address. Okay, that is it will be of type this, that will store the node's address. So what I'm gonna do is I will start traversing from the very beginning of this linked list. So at this position you can see my set will be empty, so I will just store this node's address in this set. Okay, So I will denote it over here by arrow, and I will move out to the next node. Okay, so you can see this node is still not present in this set, so I will just store this node's address into this set again. Okay, when I move out to this node, you can see only this node and this node is present in our set, and you are going to find out, check it out, whether this node address of 3 is present in our set or not. If it is not, then we can say that still we haven't found any linked list cycle. Okay, so you can see this is not present, so I will move out to this one and go to there, and I will store this you can see I have drawn an arrow over here, store this node address into this set. Okay, now again over here you can see only this node, and this node address is present in the set. So when we check it out, find out whether this node address is present in the set or not, you will get an answer as false, because only first 3 nodes are present in the set. You can see this is not present, so I will store it in the set, and similarly I will store in the set this one also, this one also, and this one also. Okay, now my current pointer is over here. You can see I am going to move out to the next pointer, and the next node address is you can see I'm going to jump from this to this one. Okay, so when you are at this node, you can see that you have already stored all the nodes address, this node address, this node address, this one, this one, this one, this one, and this one. Okay, and now your current pointer is over here, and you are going to check it out whether this node address of 3 is present in our visited set or not. So you can see yes, it is present in our visited set, and it is the very first node that I have encountered which is already being visited. So this is our answer. Okay, so node address of 3, let's say node 3 for now, is going to be like starting point of the cycle. Okay, and this is our answer. Also there might be the case like you are not going to encounter any cycle present in this list. In that case you need to return -1, and if you are going to face it out, then you are going to return the first node that is being already visited, and you are going to visit it right now again. Okay, so you can see node address 3 is present, and this will be your answer in this case. Okay, so this what would be the time complexity of this approach? You can see time complexity. Let's talk about time complexity. You can see I am maintaining a set of node address, and searching and insertion takes a logarithmic time, log of n, where n is the length of the linked list. So my time complexity would be like let me first erase it out because it may confuse, n log of n. And what is my space complexity? Space complexity would be like you are maintaining a set of visited nodes address. Space complexity would be like O of n. Okay, but this is not we want. Actually we want some better solution that works in O of 1 memory, and O of n would be the time. Okay, so how we can optimize it? So let's understand this one in detail. Okay, so you guys must be aware about the Floyd. Okay, so Floyd. What was that? Floyd algorithm? I don't know. Whether it was Floyd algorithm or like it was like tortoise and hare algorithm. Cycle detection. You can see yes, Floyd algorithm. You can see. Yeah, you can also call it that cycle detection. Yeah, and in more good case you can see we can call it as Floyd algorithm. Okay, so what I'm going to talk about is about the Floyd algorithm. You can also call it as tortoise and hare algorithm. So what we are going to do is like suppose we have a linked list. Okay, let me just draw it quickly. Okay, Now Floyd algorithm says that suppose we have two pointers, slow pointer and fast pointer. Let me write down. We have a slow pointer and we have a fast pointer. Okay. So Floyd algorithm says that whenever we have two pointers, slow pointer and fast pointer, and this fast pointer is moving as 2x speed with respect to slow pointer. That is, if the speed of slow pointer, let's say speed of slow is x, and speed of fast pointer is 2x, and if there is a cycle present in this linked list, you can also say if there is a cycle present, then slow pointer must meets fast pointer at any place, like maybe it will be over here, slow and fast meet over here, maybe slow and fast would meet over here. It will meet at any place in this cycle if there exists a cycle in this linked list, and if it doesn't, you can see fast pointer will complete the linked list with 2x speed with respect to the slow pointer. And if it doesn't, you can see the fast pointer and slow pointer will always remain in this loop, and if it always remain in this loop, the distance between the, you can see the distance of separation, you can also say distance of separation will always decrease when the slow pointer and fast pointer are inside this loop. So it is obvious that slow pointer and fast pointer will meet at any node. Okay, this is exactly the Floyd algorithm says. So what we are going to do is, like, first we will check it out whether there exists a cycle in this linked list or not. Okay, so what we are going to do is, like, let's mark out found as false. We will which will check it out whether there exists a cycle or not. Okay, so I will just move out the fast pointer twice with twice speed with respect to the slow pointer. So I will check it out. If fast exists and fast next also exists, I will step up by one place the slow pointer. You can see slow equals slow next, and fast by two steps. Fast equals fast next. Okay, that is moving the two steps ahead, and slow by one step ahead. And if there exists a cycle in this linked list, then slow and fast pointer will move inside this cycle, and their distance of separation will always decrease. In that case, you can see slow pointer must meet fast pointer at any node present in this cycle. This is actually the hare and you can say tortoise algorithm, where the hare jumps by two steps and tortoise will move by one, and they will eventually meet at some position if they are moving in some circle. Okay, so if the slow pointer is exactly equal to fast pointer, we will just claim found as true and break. Yes, we have found the linked list because they are meeting it at the same node. And if it doesn't found, we are going to return null ptr. Okay, now the problem lies over here is that if both the pointer meets at some position in this cycle, the cycle exists, but how we are going to find out this one? You can see this is the node that we want, starting point of the cycle. Okay, so this is this. You can like, if you use a set of visited nodes, you can see, you can like easily find it out, this one, because you will store the set of visited nodes, and whenever you encounter the another like whenever you are visit some node and this node is already visited, that like as I've already explained in the previous example, you can see like this node is already visited and you are going to visit it again, then this will be our starting point of the cycle. But here we are going to find out a different let us call as O of n time and O of 1 solution. Okay, so our approach in this case would be like, we are focusing on O of n time and O of 1 solution, O of 1 space solution, and we will try to find out this starting point of the cycle node in like constant space and linear time. Okay, so there is some maths behind that, so let us try to understand that mathematical approach. Okay, so suppose how we are going to explain. So we have some nodes over here. Okay, so let me just draw it clearly so that will be going to be visible to you. Okay, I hope you guys can see. Actually, my diagrams are very bad, but still, I will try my best to explain the approach behind that. Okay, so you can see there is some linked list and it contains the cycle. Obviously, we are talking about the cycle right now. Okay, so let's claim that this is the meeting point. This is the meeting point, right? And let's call as the length of cycle as L. Okay, and let us say that the distance between the starting node, that is the head of the linked list, and the node where the cycle starts to begin as X. You can say this is the X. Okay, and let's call the distance between the starting node, that is the start of the cycle node, and to the meeting point is Y. You can see this is actually the Y distance. Okay, now can you derive some mathematical relation between these? You can see the between these variables. So the concept behind is you must remember in such type of problems like what is the distance moved by first pointer. You can see that speed of the fast pointer is twice the speed of the slow pointer. So the whatever the distance moved by the fast pointer will be always twice the distance by slow pointer. Now this is going to be like important. Let me mark it. So important. So this will help you in deriving everything. Okay. So distance moved by fast pointer. So can you derive what? Can you find out what is the distance moved by fast pointer? Let's call it as df, and which will be twice of ds. Ds is the distance moved by slow point. So the fast pointer distance would be, you can see, yeah. So x will be the distance from the head of the linked list to the start of the cycle. So I will say x plus, and you can see the fast pointer will move the twice with twice the speed as of slow. So it will just cover some iterations of this entire length of cycle. So let's call it as number of iterations as m times of this entire cycle into L plus, you can see the y distance it will cover to reach the meeting point y. Okay, so let me just enclose it in brackets. So this x is actually this distance, that is the head of the linked list to the start, and this ml plus y is actually the number of times this fast pointer will cover this entire circle of present in this linked list cycle, plus y is actually the distance between this start of the cycle to the meeting point. Okay, this will be the total distance covered by the fast pointer. Okay, which will be 2 times what is the distance covered by slow pointer. Slow pointer distance covered would be like x plus start of the cycle to the meeting point y. Okay, so fast pointer will move with twice the speed, so it will cover some lengths of this cycle. So can you solve this one? Yeah. So it should be like you can see 2x and x will cancel, and it will give some x, like x is subtracted, plus you can see 2y and y, it will give us y, that must be matching with ml. Note that m over here is the number of times where the fast pointer is iterated through the entire cycle. Okay, so x plus y is actually ml. So there is something more different over here. Is like, you can see I can write x plus y as m times of L. So I will just write m into L as m minus 1. Yeah, m minus 1 plus L. Sorry, m minus 1 L plus L. Okay, and x as m minus 1 into L plus L minus y. Okay, now this is going to be like very much important. You can see the x is actually the distance between the head of the linked list to the start of the cycle of this linked list, you can see, and m minus 1 l is the number of times, like m minus 1 times the first pointer has iterated, and this l minus y is the meeting point to the start of the linked list. You can see L, the length of the linked list, minus Y, that is start of the linked list cycle to the meeting point. If you subtract it, you will find out this distance. Okay, so this gives me the idea that if we, I will just strictly recommend that you must hear this point very much carefully, that is X is matching with this entire thing. So what I'm saying, that if we start one pointer, let's say some another pointer, let's say pointer L1 and pointer L2. So if we start L1 pointer from the head of this linked list, okay, and another pointer L2 from this meeting or meeting point, and if L1 covers X distance, note that L1 covers X distance, and with the same speed we will move L2. Okay, so if L1 covers X distance and we will move L2 with the same speed, so L2 must also cover X distance, right? So L2 must also cover X distance. So if L2 must also cover X distance starting from this meeting point, so L2 must be within this cycle. So L2 must be covering this entire length X, and X can be written as m minus 1 L plus L minus Y. Okay. So L2 must be performing exactly m minus 1 times the iterations of this cycle, and it will be again at this L2, but it will cover extra L minus Y distance. So it will just eventually come and meet at this start of this linked list cycle. Okay, so L1 pointer will cover X distance, and eventually if we move L1 with the same speed as of L2, that is both moving at the same speed at each time, then L2 will cover exactly m minus 1 iterations of this cycle plus L minus Y distance. And if we start L2 with the meeting point, and each time moving in the forward direction as of the direction of the arrows of the linked list, then L2 will meet at L1 exactly at the start of this linked list cycle. Okay, so this gives us the idea that we will start two pointers, L1 at the head of the linked list, L2 at the meeting point, and we will each time step one like we will move each pointer one step forward with the same speed, and whenever they will meet, they will always meet at the start of this linked list cycle. Okay, so let's look over the code. You can see I've initialized slow as head, one pointer to the head of this linked list, and I'm going to do this until they meet it. That is, when they meet, the slow pointer will cover X distance, and in that case the fast pointer, where you can see the fast pointer is now actually moving at the same speed as of slow pointer. Okay, so when slow pointer covers the X distance, you can see the distance present over here, this is actually the X distance, then the fast pointer will always cover this distance from the meeting point. So it means that exactly m minus 1 iterations of the cycle plus L minus Y. So if the fast pointer will be moving exactly at the same speed as of slow, and it is going to do m minus 1 iterations of the cycle, it will end up to this one. Then it will going to do the L minus, cover the L minus Y distance. So it will come up to this point, and they both will meet at the start of the linked list cycle. So our answer is slow, which is the start node of this cycle present in this linked list. Okay, so this will give you all test cases passed. Yeah, you can see everything is good. So if you guys have any doubts, do let me know in the comment section of the video, and thank you for watching this video.